Okay. Now we're going to do transition metal ions. Kick it up one more notch. Finally, we deal with those transition metals. Why do we deal with them, and why did we avoid them before? We're going to see why right now. We know this is 1. We know this is 2. We know this is 3. What about the transition metals? Well, theoretically, if you're counting like you should, 1, 2, 3. That's what they should do with their 2 S's. They should all be plus 2s. But because of their p orbitals, they get to do different fun things. And what are those fun things? Ta-ta-ta, more charges. So unlike sodium that has everyone in the front row, plus 1 and plus 1 only, transition metals, look, here's copper. Copper can have a 1 or a 2. And how do I say to you that it's a copper 1 or a copper 2? By writing the Roman numerals. That is the stock way of doing it. It is the much easier way of doing it than the old-fashioned way. I'm going to show you the old-fashioned way because you will see them up here in real life. But we, as science people, now write them this way: copper 1 with the Roman numeral and copper 2 with the Roman numerals. And we'll see if you remember your Roman numerals. Lucky for you, we're only going to 6. So let's take a look. Copper. Copper can be plus 1 or plus 2. And notice the Roman numerals, I'm telling you what they are. So you don't have to guess because I'm going to tell you. Iron 2 can be iron 2 or iron 3. Plus 2 plus 3. Special cases, these are for those folks who are going to use this in college. Silver is always a plus 1. Zinc is always a plus 2. So since they don't have multiple charges, the proper way of writing them is not with the Roman numerals, because you know it's a plus 1 and you know it's a plus 2, but that's assuming you have that memorized. So if they're there, that's me making life really easy. If they're not there, then you have to remember that they're 1 and 2, and I'll show you a little shortcut to that. Okay, so how do we do the writing the formulas with the transition metals? Same way we did before, just we're using, instead of looking at the periodic table for the charge, I'm going to tell you what the charge is, because the transition metals can have more than 1. So copper 1 means you do copper plus 1. Chloride is the same, Cl minus 1, plus 1 minus 1, the charges cancel. You get CuCl. Copper 2, chloride, copper 2 plus 2. Cl is still a minus 1. Oh no, now the charges don't cancel. So what are you going to have to do? You're going to have to crisscross. So the 2 comes down, the 1 comes down, and the 1 disappears. Bye-bye. And then the 2 stays there, so it's CuCl2. So this is copper 2 chloride, not because there's a 2 here, but because the charge is a 2. And this is copper 1 chloride because of the plus 1 here, not because there's a 1 here. So just be careful. Don't assume that. It's because of the ions. First you write the ions, then either they cancel or they crisscross. And it's the same thing, except now I'm giving you charges. So here are the charges. And there's a lot of them. Plus, I'm going to give you some of the old names so you'll appreciate why this is so much easier. Copper 1 is plus 1. Copper 2 is Cu plus 2. Iron, plus 2. Iron 3, plus 3. Cobalt can be 2 and 3. Lead can be 2 and 4. Tin can be 2 and 4. Chromium can be 2 and 3. Notice they're all pluses. They're metals. Metals are losers, so they're all going to be plus charges. They're going to be cations. So the old-fashioned name, which you will see in labels, cuprous, cupric, ferrous, ferric. So these are the us and ick names, which when we get to acids, you'll see where they fit in. You'll see them on labels in a second. I'll show it to you. So just be aware that these names exist and that the lowest charge one is the us. That's the pattern. The lowest charge is the us, and the higher charge is the ick. Doesn't mean it's 1 or 2 or 3 or 4. It's just the lower and the higher. And don't worry about having to name these little buggers now, so yay. But just be aware they exist, because you might see them on vitamins. So ferrous sulfate. So if you take vitamin supplements, ladies or people with anemia, you have low iron, you take an iron supplement, which you should be doing. And look, if you look at the label of what it is that you're eating ferrous, look at that, sulfate, which really is iron 2 sulfate. So that's the old-fashioned name that shows up on a label. But, Mr. G, I don't take iron supplements. Do you eat bread? Do you eat pasta? Read what it is that you're eating, because guess what? They added ferrous sulfate, the same ferrous sulfate, into the pasta and into the bread. Why did they do that? Because you need iron in your body. What do you need iron in your body for? Aha, the red blood cells. Inside your red blood cells, that's why anemia. The iron is what helps attract the oxygen so you can breathe. That's how your blood oxygen works. It's like you breathe in, you go to the hospital, they measure your blood oxygen on your finger to see how much oxygen you are getting in your blood. The more oxygen you have, and you should be in the high 90s, that's good. Your blood would be nice and red. If you look at your veins, you'll notice that your veins aren't red. The reason why they're not red is because the blood in them is not red. So if you take it from a vein after all the oxygen was taken out of your blood, which is what happens before your lungs get more oxygen, your blood gets darker and darker and leans towards the bluish purple zone. So your blood is bluish purple. Yeah, it is. But when you have a cut, the blood comes out and it absorbs the oxygen from the air and it turns red. So that's why every time you see blood, it's red. But if you get your blood taken at a doctor's office, you'll notice, if you don't pass out during and watch what they're doing in the vial, you'll notice it's usually not that pretty red color. It's usually a darker color. And if it's a really dark color, then it's time to, well, you're seeing the doctor anyway, so just saying. Okay, so you're going to see these in labels. We will do labels later, so just be aware that they're there. Don't have to memorize them for my class, but college, maybe they'll make you memorize that. But they're on labels, so you'll see them and you'll be like, oh, is that what that means? Now, this one is a fun one. This is chromium-6. Chromium-6, yeah, chromium does 6. It loses 6 electrons, and it causes cancer. So Mr. G movie suggestion is, when you have the opportunity to watch 20 plus years old, Erin Brockovich with Julia Roberts. Great movie, talks all, and here's a link if you want to watch I'll slide up so you can see it. If you want to watch the trailer to the movie to get your interest, see if it's interesting. So be aware there is a warning because they use some bad vocabulary in there. So it is R-rated film. So, you youngins, don't be watching that film because there might have some bad vocabulary words. So chromium-6 or hexa. Oh, wait, I've seen that. Hexavalent chromium. Hex meaning 6. these things, they do fit together in a strange way. You worry about lead in your water. It's a valid concern. But what was worse is chromium. Chromium 3 is good for you. You take it as a supplement, helps your body break down sugars. But chromium 6, not good for you. So it does matter what your charge is.